Assalamualaikum warahmatullahi ta'ala wabarakatuh, and good day everyone. Today we will learn second chapter in the subject of ordinary differential equation, which is second order ordinary differential equation. Actually, in this chapter we will learn varieties of method to solve second order ordinary differential equation. Okay, but I want you to know that you can use the method that you will learn in this chapter to solve higher order ordinary differential equation as well. Okay, which is third order, fourth order, and so on. Okay, but now you will learn the first topic ever in the second chapter, which is linear homogeneous equations. Okay, this is uh, the chapter description, meaning the expected outcome for this specific topic. Actually, at the end of the chapter, actually you have to know how to determine the solution of homogeneous second order ordinary differential equation with constant coefficient. Okay, I want you to catch up some phrase which is homogeneous and constant coefficient over here. Alright, so this is actually the topic that you will learn in this chapter, and obviously today you will learn in this video of 2.1, which is linear homogeneous equations, right, as well as the introduction. Okay, introduction. The general linear differential equation of order n has the following form, which is equation number 1. Okay, keep in your mind, actually in this chapter we will cover linear differential equation. If you notice, this is linear, equation number 1 is linear. Okay, I want you to know that y, in this case, y is the dependent variable while the x is the IV independent variable, and obviously equation number 1 is linear. Alright, when a naught of x, a1 of x until an of x and of f of x are function in x. Obviously this is a function involving independent variable. If a0, a1 until an of x are all constant, the differential equation is said to have constant coefficient. Okay, I want to repeat back over here. If you notice, if the an of x, an minus 1 of x, an minus 2 of x, an of a1 of x, a0 of x is all constant, so obviously this is called constant coefficient. That is correct, because the coefficient of all the form, the coefficient, all the derivative as well as the dependent variable is all constant, so this is called constant coefficient. Okay, so otherwise it is said to have variable coefficient. Otherwise meaning not all the a0, a1 until an are constant, so it is said to have variable coefficient. Okay, so now we move to the next paragraph. For n equals to 2, equation number 1 become linear differential equation of second order. Right, so n equals to 2, you can imagine that we have over here a2 of x, d squared y over dx squared is the highest derivative in the equation, so it will call second order, obviously, right? If, okay, this is important, if f of x equals to 0, equation number 1 is called homogeneous differential equation. Okay, I repeat this one back. If equation number 1, this is equation number 1, which consists f of x equals to 0, this is called homogeneous. But if f of x not equals to 0, equation number 1 is called non-homogeneous. Okay, this is different homogeneous compared to the in the first chapter. Okay, so now this is the explanation for the previous slide. Okay, let's say I want you to focus on this one. x squared d squared y over dx squared plus x dy dx plus in bracket x squared minus 1 times y equals to 0. This is obviously linear, right? This is linear, right? Okay. And remember that if f of x equals 0, okay, you can see over here, this one, f of x equals to 0. So it is called homogeneous. Alright. And one last thing is the coefficient. Okay, if you notice, we have x squared, the coefficient of the second order derivative. We have x over here, right? And then we have x squared minus 1 over here for the coefficient for the dependent variable. So this is called variable coefficient. Okay, remember that if one of them only is not equals to constant, meaning not everything is equals to constant, are not equal to constant. So this is called variable coefficient. I hope you can get the idea. Okay, so now look at the second example. So if you focus over here, this is non-homogeneous. Why is that? Because we have e minus x sin x as fx, meaning this is not equal to 0, right? So this is non-homogeneous. And this is linear, obviously. And this is constant coefficient. Why is that? Because the coefficient over here is 1. The coefficient over here is 3. The coefficient over here is 5. All constant. So this is called constant coefficient. Okay. So now we move to the other theory that you should understand before we go to the solution. Function y1, y2, y3 until yn are said to be linearly independent if the equation c1 times y1 plus c2 plus y2 plus until cn times yn equals to 0 has only a trivial solution for which c1 equals to c2 equals to every single c in the equation equals to 0. Conversely, the functions are said to be linearly dependent if there is at least one of c1, c2 until cn is not equal to 0. Okay, we will repeat back. If we have two category over here, if linearly independent, if c1 equals to c2 equals to c3 blah 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 until cn equals to 0 to fulfill this equation. But it is called linearly dependent if at least one of c1, c2 until cn not equal to 0. Okay, I hope you get this one. Okay, so now we go to the specific example. Okay, so let's see. Let's focus on the command first. Determine whether the following sets of the function are linearly dependent or linearly independent. Okay, remember that linearly independent over here, independent meaning every c's are 0. Why linearly dependent, at least one of the c is not equal to 0. Okay, look at this one. We focus on the A. Okay, let's say this is your y1, this is your y2. Okay, so now let's say you have this one. Okay, since the previous slide they are using C, let's say this is your A. C1 y1 plus c2 y2 equals to 0. Okay, so obviously c1 and the y1 over here is cos x plus c2 over here is also cos x. Okay, I want you to relate with the previous note in the in the notes work step. They are using K1 and K2. Okay, uh, and obviously we have the K1 equals to 1, K2 equals to minus 2. So this is the case called linearly dependent. Remember that linearly dependent where when at least one of the C's is not equals to 0. So obviously these two C1 and C2 or K1 and K2 is not equal to 0. So this is called linearly dependent. Okay, so now why don't we check the second one? Okay, the second one, B. C1 times 4x3 plus, not plus, sorry, minus 2c2x3. Alright, so if you notice, we have 4c1 equals to 2c2. Okay, so we have 2c1 equals to c2. If c2 equals to 1, equals to c1 equals to 1, so our c2 will be 2. Okay, so meaning this is linearly dependent, and this is also linearly dependent. Okay, but the third one is this is linearly independent. Okay, I want you to try yourself and ask your lecturer to explain further about this. Okay, so now, okay, over here we will do verification about the solution with the differential equation. Okay, the command for this example is verify that each function of y is the general solution for the corresponding equation on the right hand side. Okay, let's say we choose question A. Alright, if you choose question A, we need to have y double prime, right, and minus 4y. We have to prove this one equals to 0. Okay, first thing, we know that our y equals to a exponent 2x plus b exponent minus 2x. And obviously, our y prime is 2a e 2x minus 2b e minus 2x. And y double prime equals to 4a exponent 2x plus 4b exponent minus 2x. Okay, so now we have to check, is it equals to 0 for a exponent 2x plus 4b exponent minus 2x minus 4 y, which is a exponent 2x plus b exponent minus 2x. Okay, is it equals to 0? So alright, for a over here with the minus 4a, and then for b over here minus 4 times b with this one. Yes, this is 0, so this is verified. This is verified. Okay, so meaning the solution of the y double prime minus 4y equals to 0 is equals to y equals to a e 2x plus b e minus 2x. Okay, so now we go to the method on how to solve linear homogeneous constant coefficient. Alright, consider the second order linear homogeneous equation with constant coefficient as below. Okay, remember this is second order linear homogeneous constant coefficient. Okay, first thing, let y equals to exponent mx is a solution of the given equation with m is any constant. Then dy dx, you will have m exponent mx, and d squared y over dx squared equals to m squared exponent mx. Then substitute the value of y, dy dx, and d squared y over dx squared into equation number 1. You will have am squared plus bm plus c exponent mx equals to m. Okay, and then but since emx is never 0 and y equals to exponent mx is the solution, this means am squared plus bm plus c equals to 0, which is equation number 2. Okay, this equation number 2 is known as characteristic equation or auxiliary equation. Okay, in this video, I call this one as characteristic equation, or the other shortcut name as CE. Or in other way to discuss from the discussion previously, we should notice that from general form we will have this one, which is a d squared x over dt squared plus b dx dt plus c x is equals to 0, and a obviously cannot be 0. We can find the characteristic equation, which is we call that CE. It can be reduced to be am squared plus bm plus c equals to 0. Okay, by replace the sign of this one become m squared, dy dx equals to m power 1, and the y become n power 0. Okay, so now I want you to recall the characteristic of quadratic equation. This is called quadratic equation, right? Now the homogeneous DE has apparently been reduced to the purely algebraic problem of finding the root of characteristic equation. As you know, the quadratic equation has 3 types of roots if the following conditions are satisfied. Okay, it will become distinct real root if b squared is greater than 4ac. Okay, this is b, right? Okay, this is the value of a and this is the value of c, and then you have to check the value of b squared. If it is greater than 4 times a times c, it will have distinct real root. Okay, but if b squared equals to 4ac, the root will be equal. But if b squared less than 4ac, we will have a complex or imaginary roots. Okay, therefore, the general solution of homogeneous differential equation depends on the type of the characteristic equation. Okay, so now we will discuss further about this one based on the previous notes. Okay, we have 3 cases, right? The first one is when we have distinct real root, which is specifically we have b squared is greater than 4ac. Distinct real root when we have m1 and m2, which is real and distinct, right? Okay, so then the general solution will be y of x equals to a e m1x plus b e m2x. If you notice, we have m1 over here, m2 over here. Okay, as easy as that. So this is your general solution. Okay, for the second case, if we have equal real root, which is b squared equals to 4ac. So now we just have one single root, which is m1 equals to m2. We call it as m. So the general solution will be yx equals to a plus bx in bracket exponent mx. We just have one single root over here. Okay, done. So now the last case will be complex root, which is b squared is less than 4ac. Okay, the root, the root will be the imaginary set, which is this one is a real number. the beta will be the imaginary number. Okay, same goes to the beta over here. Okay, actually in this case we will have m equals to alpha plus minus beta I. Again, alpha is the real number and beta is the imaginary number. So the solution, the general solution will be exponent alpha x times in bracket a cosine beta x plus b sine beta x. So you have to remember all these three patterns as well as the general solution of each patterns. Okay. Okay, let's say this is the first case, right? Okay, just now this is the find the general solution of this one. So obviously this is linear, constant coefficient, homogeneous, yes. And then what you have to do is just reduce it, become characteristic equation. It will become this one. Okay, and then factorize this one out and then find the root. Obviously this is case number 1, which is this thing, real roots. Okay, so you will have this one as the general solution, as easy as that. Okay, so actually from here, from this one, you can just jump to the solution by using the calculator. Okay, you're able to use the calculator. Okay, to calculate the root of the previous characteristic equation, you should find EQN and then find the quadratic equation, which is 3, and then substitute the coefficient just now, 1 equal 3 equal minus 4t. Alright, so the answer is x1 5, x2 equals to minus 8, meaning x1 and x2 is the root. 5 and minus 8 is case number 1, which is distinct real roots. Okay, now so this is the second case, which is equal real root. We have this one as the question. Okay, and then obviously the characteristic equation will become 4m squared plus 12m plus 9, right? Exactly, you just have to replace the notation to be m. Okay, and then by using calculator, you will have the m equals to minus 3 per 2. Obviously just one root. This is equal real root. So remember the general form, y of x equals to exponent mx times a plus bx. Okay, so obviously this one actually you can change to be a plus bx exponent mx, right? This is equivalent. Okay, so obviously this is your m, minus 3 per 2x. Okay, for the second question, again find equation 5 and then 3. This is my version of calculator. You can check your own calculator. So now this is the just now the coefficient is 4 equal 12 equal 9. Okay, so when you press the equal button, you will have x only. Okay, this is other form of the, okay, this one, minus 3 per 2. Okay, and then if you press again, you will have this one back. Okay, this is the, okay, this is the other form of the answer, right? Okay, this one is the case number 3. Find the general solution of 2 d squared y over dx squared plus 4 dy dx plus 3y equals to 0. Then first step, as usual, you have to build the characteristic equation. And okay, as usual, we substitute the number 2, 4, 3. Okay, so now you can see that we have minus 1 plus square root 2 per 2i. That minus 1 is the value of alpha, which is the real value, while the beta, which is square root 2 per 2, is the beta value. And when you press again, which is x2, we have minus 1 minus the beta value. Okay, previous one we have minus 1 plus beta I, and then minus 1 minus beta I. Okay, remember that just now we have x1 equals to minus 1 plus square root 2 2i, isn't it? And x2 equals to minus 1 minus square root 2 2i. Okay, so actually when you combine, you will have this 2 into this one. Okay, square root 2 per 2 is actually 1 per square root 2. Please discover this one yourself. Okay, how is it? So obviously your beta equals to minus 1. Your alpha equals to minus 1. Sorry, your beta equals to 1 divided by square root 2. Do not take the I, the notation I. Just take the value alpha and the beta. Okay, and then when you write the general solution, remember that if we facing this case, we will have exponent alpha x, a cosine beta x. This always happen. Cosine beta x plus b sine beta x, right? So the alpha is the real value, the beta is the imaginary value. Okay, so this will become the general solution. Okay, so now we go to how to find the particular solution for this kind of differential equation. Find the particular solution of the differential of the following equation satisfying the condition. Okay, since this one is second order, right? This is second order ordinary differential equation. So we need two condition, which is this one is the first one, this one as the second one. Okay, so now as usual, you have to find the characteristic equation first, right? We have this one, and then use your calculator. Actually, you don't need to calculate this one manually, just go to the answer. So you will have this one, 2 plus minus 3i. This is case number 3, which is a complex root. Okay, so this will become the answer, right? This will become the answer. The alpha just now equals to 2, the beta equals to 3. So this one will be the answer. Okay, so now remember that we have a condition. This is the first condition, right? And this one is the second condition. Okay. Okay, if you revise back in the first chapter, we just need one condition only. Why? Because we just have one unknown constant, isn't it? But now over here, you have two unknown, which is A and B. So that's why we need two conditions. Okay, so the first one, you just have to substitute x equals to 0 and y equals to 1. And then the second one, x equals to 0, but y prime equals to 2, meaning you have to find y prime, meaning you have to differentiate y to have y prime. So luckily, over here, you need to use product rule. Why? Because we have exponential. over here multiply with the a cosine 3x plus b cosine 3x. So this one, equation number 2 over here is the y prime. So you have to substitute equation number 1 and equation number 2 into both equations to have the answer for the a and the b. So after calculate, you have the a equals to -1, the b equals to 4 per 3. So, and then you have to replace everything to have the particular solution. So this one will be the answer. Okay, so now this one is just the summary of what we have go through today. So if we have real and this thing, this is the general solution. We have equal real root, meaning we just have one root, one single root. This is the general solution. But if you have complex root, you will have this general solution. Okay, but for the complex root one, you have to recognize your own calculator, because different calculator will give you different way to read. Okay, discuss with your lecturer for that matter. Okay, so now we have exercise 2.1 to cover this topic, and then the question number 3, find the general solution, meaning we don't have the condition, right? Just a simple one, calculate the general solution. But question number 4, find the particular solution by the given conditions. Okay, so now I want to try to answer this one. Okay, let's say this one CE. Okay, m squared plus m minus 6 equals to 0. Use your calculator. 1 minus 6. You will have m1 equals to 2. m2 equals to minus 3. So this is case number 1. You don't have to write the number of the case. Just write the general solution, which is a exponent 2x plus b exponent minus 3x. Just that. Okay, so how about this one? Characteristic equation. 4m squared minus 12m plus 9 equals to 0. Okay, so this is 4 minus 12, 9. Okay, we just have one root, which is 3 per 2. 3 per 2. So your y equals to a plus bx exponent 3 per 2x. Okay, this one CE. M squared plus 4 equals to 0. Okay, be careful. We don't have any dy dx, so we just jump m squared plus 4. Okay, this one you can calculate manually, or you can calculate by using calculator. We have 1, 0, and 4. Okay, obviously this one you have, okay, be careful. This one is actually 0 plus minus 2i. Meaning this is case number 3. The real value is 0, but the beta value is number 2. This is your alpha, this is your beta. Okay, this is yx equals to exponent 0, 0x a cosine 2x plus b sine 2x, or you can simplify this one, become a cosine 2x plus b sine 2x because of exponent 0 equals to 1. Okay, so next one will be this one. CE m squared minus m minus 6 equals to 0. This is just similar like before. This is 1 minus 6. Okay, this is just simple. M equals to 3, m2 equals to minus 2. Case number 1, right? Yx equals to a exponent 3x plus b exponent minus 2x. Okay, we done. Right, so now we move to the next question. We choose question A. Find the particular solution for each of the following differential equations. Okay, just one, question A. First thing, obviously, you have to find this characteristic equation. M squared plus m minus 12 equals to 0. So, we use calculator. 1 minus 12 and m1 equals to 3, m2, this is case number 1, minus 4, real and distinct. So y, actually we can just write y equals to e exponent 3x plus 4, not 4, b exponent minus 4x. We don't need to write y of x. We just can write y only. Okay, this is the general solution. Okay, so now we know that given to us the condition y0 equals to 2, which means x0, y2. Okay, why don't we substitute, key in this condition into the general solution? This is 2 equals to a exponent 0 plus b exponent 0. When we simplify, we will have a plus b equals to 2. This is equation number 1. Okay, and then we have a second condition, which is y prime 0 equals to minus 1. This one brings us x equals to 0, y prime equals to minus 1. Okay, obviously, we have to find the y1. Y prime, sorry. So y prime, meaning we have to differentiate the general solution. We have 3a exponent 3x minus 4b exponent minus 4x. Okay, and then substitute this condition. We will have minus 1, 3a exponent 0 minus 4b exponent 0. Okay, so now we simplify it. We will have 3a minus 4b equals to minus 1. This is equation number 2. Okay, so now next step, we have to find the values of a and the b. Okay, so obviously I want to copy back the equation, these two equations. A equals to b, a plus b equals to 2. This is equation number 1. 3a minus 4b equals to minus 1. This is equation number 2. Okay, you have to calculate this one, solve this one simultaneously. You don't have to calculate this one manually. You can use calculator. Okay, so now we want to calculate the values of a and b by using calculator. First thing, find equation, and then choose the right arrangement. In this case, I choose 1. Okay, and then you have to substitute the coefficient of the a and the b, which is a equals the coefficient for the a, equation number 1 first. This is equation for the b, and then this is equal to number 2, and then over here is 3, over here is minus 4 and minus 1, right? So obviously the x represent the first unknown, which is a equals to 1, and the y, which is b, equals to 1 also. The a just now equals to 1, the b equals to 1. So what you have to do is just copy back your general solution. This is the general solution. Okay, and then y equals to a equals to 1, so we just have exponent 3x plus exponent minus 4x. Okay, this is the answer. So I hope by now you can solve linear homogeneous easily. Thank you, everybody.